Hello viewers, tutorial 12 question 3, and we are doing some integration by the reverse chain rule. So we're still on our guess and check method, but we're now on functions that are beyond just powers. So the first question we're going to do is the integral of 2x times cosine of x squared minus pi. Let's forget about the 2x for now. Notice that that is just the derivative of the bracket, the derivative of x squared minus pi. Look at cosine of x squared minus pi. If we were to differentiate that, we would do it by the chain rule, and your z would be x squared minus pi and y equals cosine of z. So that means that you've got x squared minus pi inside the cosine function. Cosine is therefore the outer function. So we're going to look at the integral of the outer function. Integral of that outer function is sine. So we're going to try sine of the same sine of x squared minus pi. So we'll check that by differentiating it as we did in video 2. So if we differentiate the sine of x squared minus pi, we'll get cosine of that same bracket, cosine of x squared minus pi, multiply by the derivative of that bracket. And if we reverse that statement, so write it in terms of an integration, we get the integral of 2x times cosine of x squared minus pi dx equals sine of x squared minus pi plus constant. Now, is this what we're actually trying to integrate? 2x cosine of x squared minus pi, 2x cosine of x squared minus pi. So they match, which means that your trial solution was bang on the money. Okay, so we've got our correct answer, the integral of 2x times cosine of x squared minus pi is sine of x squared minus pi. Question B, we need to find the integral of e to the x sine of e to the x dx. E to the x is the derivative of that bracket, so for now let's just pay attention to the sine of e to the x. So by the chain rule we would have z equals e to the x and y equals sine of z. So e to the x is inside sine of z. So the outer function is sine, and if we try integrating that, we get integral of sine is negative cosine of e to the x. So that's what we're going to try. Okay, so therefore we're going to differentiate that. D by dx of negative cosine of e to the x is negative of cosine differentiates to negative sine, so negative of negative becomes a plus sine of e to the x times the derivative of e to the x. So this is going to be plus e to the x times sine of e to the x. So if we reverse the statement, write it as now an integral statement, integral of e to the x times sine of e to the x dx equals negative cosine of e to the x plus your constant. Now let's compare what we're integrating here with what we're integrating. E to the x sine e to the x, e to the x sine e to the x. It matches, which means our answer is again exactly correct. Integral of e to the x sine of e to the x dx is therefore indeed negative cosine of e to the x plus c. And speaking of c, question C, we have the integral of cosine of x times the sine squared of x dx. So let's rewrite this in another way which will make it a little bit clearer what's going on and what function is inside which function. So this is the integral of cosine of x times sine of x in a bracket squared dx. Okay, so cosine is the derivative of the inside of this bracket. Now the inside function here, what would be our z, is the sine of x, and that's inside the squaring function. So the squaring function is the outer function, and we will try, the outer function is squared, so we'll try what happens if we integrate the outer function. Integrate, therefore, that z squared, we would get z cubed times some number, so we would get a z to the power of 3. So we'll try that z is sine of x, that to the power of 3. Now if we differentiate that, we get d by dx of sine of x cubed, so we'll get that power coming out the front, which is 3 times sine of x, and that's squared, times the derivative of the inside of that bracket, which is cosine. Okay, so write that as an integration statement. The integral of 3 times, let's change our notation back, so sine of x in a bracket squared is the same thing as sine squared, times cosine of x dx equals, that will be sine of x to the power of 3, or we can write that as sine cubed plus c. Now let's compare what we're integrating. Integral of cos of x, sine squared of x. We've got the sine squared, we've got the cos, we've got an extra times 3 we don't want, so we can divide by 3. Okay, so we get the integral of sine squared x times cosine x dx equals sine cubed x upon 3 plus c. Thanks for watching. Over and out.